Bon, merci Eric. Bonjour à tous. This presentation will provide an overview of the work carried out during the last fiscal year as part of a project on aquifer and groundwater characterization in the western part of the Niagara Peninsula in southern Ontario. This project was launched in 2024 in response to a request by the director of the Environmental Committee at the time of the Six Nations community to the federal government for assistance in addressing the poor quality of groundwater in the reserve. As you will see, things have evolved differently than what we had imagined. I'll just skip the abstract for the presentation. This project involves many people from the federal government, from 3 GSC divisions and from ECCC, from 3 provincial ministries, 5 universities and 2 consulting firms, and 1 member of the Six Nations community and her postdoc, who are both associated with a university and Six Nations Polytechnic. And we have the pleasure of having 2 PhD students. The study area corresponds to the lower part of the Grand River watershed, so about 2,000 square kilometers, with 2 First Nations reserves located in the middle, Six Nations, which is the largest in Canada, and Mississaugas of the Credit, which is just next to it. This study area is mostly rural and quite populated. The study area was selected much larger than the 2 First Nations reserves in order to properly understand the context and the different water quality issues, which include those related to the geological setting, but also to human activities such as agriculture, road salting, and hydrocarbon development, as many old oil and gas wells have been or were abandoned with the methods used at the time. All these issues pose serious problems since some parts of the aquifers are gas-rich, brackish, or contain other compounds, making groundwater sometimes unfit for consumption. In particular, H2S, hydrogen sulfide, a toxic gas, is a serious health problem, and it can be present in the study area because as methane escapes from deep hydrocarbon reservoirs and migrates to the surface, it can pass through evaporite layers forming sulfates, then H2S. The shallow bedrock of the study area consists mainly of the Salina group in yellow, composed of evaporite, but also mudstone and dolostone that covers most of the southern half of the study area. And to the north of the Guelph Formation, shown in beige, mainly composed of dolostone. Superficial sediments of the study area are mainly fine grained. They are shown in light blue. So they protect groundwater very well against surface contamination, but they do not really favor infiltration. So this brings me to the hydrogeological context. As you can see from this map, this region is covered with water wells, yet a lot of people struggle with their water supply because the water quantity and quality is often poor, especially in the southern half of the study area where we focused our fieldwork last fiscal year. Many residents have their wells completed at the interface between superficial sediments and bedrock due to the geological context, but the water yield or water yield is very limited and the water quality is poor. And also some residents use their wells as cisterns that they have to fill regularly with water trucks, or some people buy water jugs for their cooking and drinking due to the poor water quality. Farms sometimes need to use ditches and ponds to collect rainwater and snow melt because the yield of their well is insufficient. So as I mentioned earlier, due to the geology and also the different activities in the region, groundwater may contain to varying degrees and depending on the location, sulfate, sodium chloride, nitrate, methane, and H2S that could be related to legacy oil and gas wells, which are abundant in this region. So based on these issues, the objectives of this project is first to understand groundwater flow in the study area. This involves characterizing the properties of shallow aquifers and assess recharge and discharge areas and rates, and integrating the knowledge gained in 2D and 3D coupled numerical models, including eventually predictive models, notably for climate change scenarios. The second objective is to study the impact of natural and anthropogenic contaminants on the region's water resources. This involves characterizing the quality of surface water and especially groundwater using air and soil gas measurements to better understand or identify the different sources of contaminants, and also explaining the occurrence of specific compounds or isotopic values in some areas. As part of the second objective, a study of the history of the landscape and environmental changes over the past few decades and the impacts on culture, health, and quality of life is being carried out based on interviews and discussions with members of the Six Nations community. In the last fiscal year, we core drilled and installed 12 monitoring wells with depths ranging from 15 to 125 meters at 7 sites, all located in the southern half of the study area. 6 wells were drilled last fall, and work had to be resumed in January in harsh conditions because everything did not exactly go according to plan for a variety of reasons. The selection of sites was mainly based on geological and geochemical interests, a good spatial distribution, and of course we had budget constraints, so we wanted to find locations where the Guelph Formation was not too deep below the Salina Group. This project was rejected by the Six Nations Ethics Committee, in part because it is difficult for the federal government to comply with the OCAP principles, in which O stands for ownership of data. So we had decided to select most of our drilling sites very close to the reserve in order to try to understand the hydrodynamics inside the reserve as well as possible. So we first drill at site number 1 because this specific area is known to contain anomalous sulfur isotopic values of sulfates. Then we moved to site number 2, which is located very close to the reserve. And we were rapidly notified that this site is located on contested land and was the subject of real estate disputes in 2014 and 2020. So we realized it wasn't a great idea to drill there. But we were authorized to drill the wells and we sampled them right after. But we told the office of the elected chief that we would not go back to the site unless we were invited by the community. And we decided to relocate the 2 sites in green elsewhere, of course. So that's the reason why we had to stop drilling at the end of October after drilling at sites number 3 and 4 because we needed time to obtain the drilling permits for the new sites and also sign agreements between the federal government and the counties. That's why we had to go back this winter for the last 3 sites. As a result, more than half of our wells are located outside the Haldeman Tract or contested land. Field work last fall, in addition to core drilling, included work related to these wells, such as quaternary sediment and rock sampling, borehole geophysical logging, slug test, and the installation of pressure transducers and other sensors. Fieldwork also included Guelph per meter tests, soil gas measurements, a thermal camera survey and a magnetometer survey, both using a drone, and they were carried out in February, so in very cold conditions. And finally, groundwater sampling, which I will talk about in the next few slides. So last fall, we sampled 5 monitoring wells because one well ended up being dry because it was a very dry summer. And we sampled 2 residential wells because 2 residents came to us because they were interested by the project and concerned, even worried about the quality of their water. We could not sample for the complete series of analyses because the monitoring wells had been drilled very recently using a large quantity of surface water, meaning that some results would not have been representative of the water in the aquifer, such as for water isotopes, tritium and carbon-14 that are used for groundwater age or dating. However, a sampling campaign is currently ongoing, so we'll have these results very soon. Despite the limited data set that we have for the moment, we can confirm that the groundwater quality is generally poor for different reasons, including the TDS content, TDS for total dissolved solid, that is quite high, generally above 1,000 milligrams per liter in bedrock wells. So it is considered brackish, and the presence of nitrate, methane, ethane, propane, and H2S in variable concentrations. But groundwater is often bubbly and smelly in this region. The Piper diagram shows that groundwater in our monitoring wells is dominantly of the calcium sulfate type in bedrock wells and also in wells completed at the interface with bedrock because they are completed into the saline group that contains evaporites. They also have very high values of TDS, reflecting water-rock interactions. While groundwater is mainly of the calcium bicarbonate type in superficial sediment wells, and the values of TDS are much lower, indicating less geochemically evolved conditions. These water types are in total agreement with values from the province. Methane and higher hydrocarbons were detected in only a subset of the wells that we sampled, so it indicates a very large spatial variability. And the maximum concentration in methane that we found is 3 milligrams per liter, so it's not considered high at all. Both the Bernard and Withegard graphs that are typically used to help identify the origin of hydrocarbons suggest a mixed microbial thermogenic origin or strictly microbial with some oxidation taking place that could affect the isotopic signature. So as we acquire more data, we will... Pardon?
2 minutes, Justin.
Ah, parfait. Merci. We will be able to better understand the processes and therefore origin of these hydrocarbons. Last slide. In the area shown in red on the map that we call the corridor, some wells were found to have abnormally low or very depleted sulfur isotopic values of sulfates. These are thought to be derived from upward migration of dissolved sulfates from the terrestrial Queenston Formation that is located at the depth of about 400 meters in this region, because these values could not be of marine origin. However, as part of this project, the aim is to understand how this upward migration can take place. To do so, a study of the geological history and the presence of faults in this region is being carried out. Data from deep lithoprobe seismic and high-resolution aeromagnetic surveys have been used to identify faults rooted in the Precambrian basement, some of which cut the entire Paleozoic platform. These are mainly restricted to the corridor. And these faults have been active many times over the geological history, and recent seismic events have been recorded. evidence of hydrothermal conditions in the Guelph Formation are provided by the very depleted values of calcite isotopes, circled in red on the graph, as they are associated with high temperature dolomite. Hydrothermal conditions can significantly increase porosity and subvertical fractures. So these faults, or at least some of them, could act as conduits, potentially allowing upward migration of brines up to a certain depth. We're waiting for new geochemical data, which will help us identify the underlying processes or process at play. Thank you very much.